Welcome back to my channel, everyone. Today we're going to be looking at faulting and earthquake. A fault is a deep fracture along which rocks on either side are displaced. Faults are associated with plate margins and they develop as a response of the brittle rocks of the crust to the stresses created by the plate movement. So at convergent plate margins, where the plates are moving towards each other, this creates compression. Compression causes the rocks to be squeezed together. At a divergent plate margin, where the plates are moving away from each other, a stress known as tension is created, and tension causes the rocks to be stretched. At a transform plate margin, where the plates are sliding past each other, shearing stress occurs. Shearing stress involves rocks moving parallel to each other but in opposite direction. And these different stresses occur in our everyday life. Now, it's important for us to make a distinction between a fault and a joint. The similarity between the two is that both faults and joints are fractures in rocks. But while displacement occurs at faults, displacement does not occur at a joint. A fault plane is a flat surface along which rocks slip. And when we talk about slip, we are talking about the movement of rocks on either side of the fault plane. So the slip is a movement and the fault plane is the surface along which the movement or the displacement occurs. The diagram shows the two types of slips that are associated with faulting. So if the displacement occurs in a horizontal direction, we say that it's a strike slip. If it occurs in a lateral or a up-down direction, then we say that it is a dip slip. And so the strike is indicated by the orange arrow, while the dip is being demonstrated by the blue arrow. Now we usually classify the different types of faults based on these two types of slips. So we can broadly classify faults into dip slip faults and strike slip faults. Dip slip faults can be further classified into normal faults and reverse faults. Oftentimes, we do not classify strike slip faults, but we can. And if we do, we will talk about right lateral faults and left lateral faults. So let's first talk about the dip slip faults. Now, we will have dip slip faults when the fault itself is slanted, as this diagram is showing. When the fault or the fracture is slanted, it creates two different types of blocks, and it's very important that you know these blocks. So we have the footwall and we have the hanging wall. The footwall is defined as the block of rock below the fault line, and the hanging wall is defined as the block of rock above the fault line. Now, if you don't understand that, just look at the diagram and you could describe the footwall as the block of rock that has a narrow base and, a narrow top and a wide base, while the hanging wall is the block of rock with the wide top and the narrow base. So let us say that we have an area of land where there is a fault, but the fault is slanted. And remember, as long as the fault is slanted, it is going to create footwall and hanging wall. If the force of tension should impact that area of land, remember, tension is a stretching force. What will happen is that this tension will cause the footwall to move up and the hanging wall to move down. Or it could be the footwall moving up relative to the hanging wall, or we could say that the hanging wall moves down relative to the footwall. So this is called a normal fault. So remember that the normal fault is a result of tension, which means that it commonly occurs at divergent plate margin. Tension causes the footwall to move up relative to the hanging wall, and this causes the land to be stretched. Now, if we have a situation where the same type of fault exists, where we have a slanted fault, that is, but this time the force that is affecting the rocks is the force of compression. So it might be at a convergent plate margin. The opposite is going to take place because compression is squeezing the rocks together. What will therefore happen is that the hanging wall will move up relative to the footwall, or we could say that the footwall moves down relative to the hanging wall. This type of fault is called reverse fault because it is the direct opposite of the normal fault. So, reverse faults are the result of compression, and it causes the hanging wall to move up and the footwall to move down. It also causes the land to be shortened. Now, if the fault line, instead of being slanted, is vertical, and the stress that is acting on the rocks is shearing stress, then the slip is going to occur along the strike instead of along the dip. That is, the movement is going to be horizontal. Notice that when the fault or the crack is vertical, we no longer talk about the footwall and the hanging wall. So when shearing stress occurs and the blocks of rock slide past each other, moving parallel but in opposite direction, we have a strike slip fault. If you are standing on one block of rock in front of the crack and you are looking over on the other block and that block is moving to your right, then we classify that as a right lateral fault. If, however, it's a situation where when you stand on one block and you look at the other block of rock and the other block of rock is moving to your left, then it is called a left lateral fault. Now, in some situations, we can have faulting occurring in both directions. So movement could be occurring along the strike and along the dip at the same time. In that case, we will call the fault an oblique fault. Now, faulting can result in the development of various landforms. Some of the major landforms that are created by faulting are horst, tilt block, and rift valley. Now, Jamaica occurs in an area that is affected by faulting. In fact, Jamaica itself developed in three main stages. At one stage, it was a part of a volcanic arc. At another stage, it was submerged beneath the sea, and a number of sediments started to be deposited on the surface, including limestone. And in the final stage, tectonic forces caused the island to be uplifted. So the island of Jamaica is actually the result of a faulting activities. And as you can see in the map, it is located within a zone where there are faults, and we have some faults that connect Jamaica, for example, with Hispaniola. So Jamaica itself is broken into a number of faults, And so there are landforms in Jamaica that result from faulting. Now, one of the landforms in Jamaica created from faulting is a horst or a block mountain. Now, a block mountain is formed when an area of land is broken into a number of faults, and a central block between two normal faults most times is uplifted. So it creates a highland with a generally flat top. So an example of this is Long Mountain. Long Mountain is located at the outskirts of Kingston. Another type of highland that is the result of faulting is a tilt block. Now, the tilt block is similar to the horst or block mountain in that it involves a block of rock being uplifted. But in this case, it is lifted more on one side than the other. So it has a tilted shape, and one side is steeper than the other. A good example of this is the John Crow Mountain in Jamaica, which runs parallel to the northeast coast. While it is steeper along the southwest, it is gentle along the northeast. Another landform created by faulting is a rift valley or graben. Now, an example of a rift valley or a graben is the Jordan Rift Valley. We also have rift valleys in East Africa. Now, unlike the horst, where the central block moves upwards, in the case of the Rift Valley, the central block moves downwards. And so this creates a flat floored valley. Now, the Rift Valley can also be called a graben. Faulting not only creates landforms, they are also important because they can result in earthquakes. And therefore, it is important to bear in mind that since faults are themselves the result of plate movements and earthquakes result from faulting, it means that we have earthquakes occurring at all three plate margins. So let's consider a situation where we have a normal fault, bearing in mind that it's not the only type of fault that can result in earthquake. So let's say we have a normal fault. Remember, tension is acting on the rocks, causing the footwall to move up relative to the hanging wall. What happens is that even though this diagram is showing that the fault plane is smooth, in reality, the fault plane is not smooth. So as the rocks move against each other due to the stresses acting on them, they often become stuck by friction and they are locked. Now, because they are locked and stress is still acting on them, it causes pressure to be built up. If the stress overcomes the friction, then the rocks may be unlocked, and all of that energy that was built up will be suddenly released. That sudden release of energy is what we call earthquake. The earthquake will result in waves or seismic waves moving throughout the crust of the earth. Now, the point where the energy is first released is called the focus of the earthquake. The point that is directly above the focus on the surface is called the epicenter. And that is where we feel the earthquake strongest on the surface. All right, thank you for watching. Don't forget to like, share, and subscribe.